In the module number 3, let me see the syllabus, show the syllabus. This is the module number 3. Here we have one topic like preemptive task scheduling techniques. Okay, in the syllabus actually only preemptive task scheduling techniques are there. In the textbook, I'll explain what are the different task scheduling techniques are there. I will explain both the preemptive and non-preemptive. So that non-preemptive is augmented syllabus, and preemptive is actually without knowing unknown non-preemptive, it is difficult. So let me solve some problems on non-preemptive task scheduling techniques. After that, in the exam, you give more preference for preemptive task scheduling technique problems. So let me go through the syllabus. So these are the different task scheduling techniques. That is first come first serve. It is also called as first in first out. Then last come first serve. That is also called as last in first out. SJF means shortest job first, and priority based task scheduling techniques. Actually, scheduler will be there, which will actually schedule tasks, and it will make all the tasks to run properly according to the which scheduling technique they are using. There are 5 terms, okay, which are very important in these problems. They will ask you to find turnaround time, average waiting time, and average turnaround time. So, what is turnaround time? Turnaround time is it is the amount of time taken by a process for completing its execution. It includes time spent by process for waiting for the main memory, time spent in ready queue, time spent on completing the IO operations, and time spent in execution. For a good algorithm, turnaround time should be minimal for a good scheduling algorithm. Next term is waiting time. Okay. It is the amount of time spent by a process in the ready queue waiting to get CPU time for execution. And for a good algorithm, waiting time should be always minimum. The turnaround time also should be minimum, and waiting time should be minimum. If you are designing your own algorithm, you should maintain turnaround time of and waiting time should be less. And other terms are CPU utilization. A scheduling algorithm should always make CPU utilization high. CPU utilization is direct measure of how much percentage of CPU being utilized. Second term is then throughput. It gives indication of number of processes executed per unit time. Throughput for a good algorithm should be always higher. So CPU utilization should be higher, throughput should be higher, but turnaround time and waiting time should be less. And last term is response time. It is a time elapsed between the submission of process and the first response. For a good schedule algorithm, the response time should be as least as possible. So, summarizing, they will ask only find out average turnaround time and average waiting time. So, to summarize, a good scheduling algorithm should have high CPU utilization, then minimum turnaround time, and minimum waiting time, minimum response time, and maximum throughput. So let us go to the problem one by one. So I'm going to explain non-preventive scheduling. Non-preventive scheduling in the first come first serve. First come first serve. That means suppose 5 tasks comes, which comes first that will be served, or first in first out. Okay. So let us go to the first problem. So it is a non-preemptive. Actually, you give preference for preemptive. Preventive is there for your syllabus, but non-preemptive, if you understand, you can easily understand preemptive. So in the non-preemptive means it cannot be stopped. Or if suppose 5 tasks are running, If fifth one comes, it cannot be stopped. So non-preemptive means we can stop and immediately resource will be given to the next process according to the priority or any other algorithms. Okay. So in the non-preemptive, whatever task is running, that is should be completed. Then only that resources will be shared to the next one. In the preemptive, it immediately at the instance, if any higher priority comes, immediately that will preempt the old running and it will start running. So in the preemptive is there for your syllabus. So let us go first with augmented syllabus non-preemptive scheduling, which is first come first serve or first in first out scheduling. First problem: understand the statement properly. Three processes with process IDs P1, P2, P3 with estimated completion time of 10, 5, 7 milliseconds respectively enters the ready queue state together in the order first P1 comes, next P2, next P3. Okay, P1 10 millisecond, P5 5 millisecond, P3 7 milliseconds, and they came in the order P1 first, P2, P3 according to the number only. Calculate waiting time and turnaround time for each process. Okay, and the average waiting time and average turnaround time, assuming there is no iBarrow waiting for the process. Okay, let us start. So P1, note down, P1 10 millisecond, P2 5 millisecond, and P3 7 millisecond. Okay, now all they appeared according to the P1, P2, P3. That is what is the meaning of this first come first serve, right? It is first come first serve. Which one is came first? First P1 came, next P2 came, next P3 came. So the scheduler which following this algorithm, first it will share the resources to P1, next it will share the resource to P2, next it will share the resources to P3. So first let me assume that all the three appeared here in the order first P1. So first P1 will execute, next P2, next P3, but actually they appeared in the order of P1, P2, P3. So first this is a time, this is a time duration starting from 0. How much time it is taking? P1 task is 10 millisecond. So right, this is 10 millisecond for P1. The scheduler actually shares the resources. This 10 millisecond is given for P1 process. P1 now it is utilizing CPU, so it will execute this. After that, which came P2, it is coming in the order P1 next, P2 next, P3. It is coming in the order together. So next P2 will execute, that will execute for 5 milliseconds. So next 5 seconds for 5 millisecond for P2. After that P3. So P3 7 milliseconds. So you have to find out what is the waiting time. Even though it's coming in the order P1, P2, P3, P1 is first. No, so waiting time for P1 is 0. Waiting time for P1 is 0 because it came first. First come first serve. So 0 millisecond. P1 no need to wait for any milliseconds. So immediately without waiting, resources will be given. So P1 will execute. So waiting time for P1 is 0. So next, what is the waiting time for P2? So actually all three entered together in the order P1, P2, P3. So here only P1, P2, P3 all came together here. So first P1 came now. So without waiting point, P1 is 0. But even though it came in the order P1, P2 together, but resources up to here, 10 millisecond CPU and resources, iBarrow resource, everything is given to P1. The scheduler will schedule. So P2 cannot start until P1 completes job. So it should wait 10 millisecond. Then only the scheduler will allocate the resources to P2. So P2 should wait how much? 10 millisecond. Okay. Waiting time for P1 is waiting time for P2. Waiting time for P2 is 10 millisecond. 5 milliseconds. Okay, this is 5 milliseconds. Sorry, P2 should wait 10 milliseconds to get the resources. Okay. Next, coming to the P3. P3 should wait because P1, P2, P3 appeared here only. So it should wait P1 to complete, P2 to complete. So P1 10 millisecond, it should wait. P2's 5 millisecond, it should wait. So it should wait 10 plus 5, 15 milliseconds to get its chance. So scheduler will schedule after 15 millisecond. Okay. So that is the waiting time of P3. I will repeat once again. P1, P2, P3 appeared together starting from here. They came in the order P1, P2, P3. So since P1, this algorithm is first come first serve, waiting time for P1 is 0. But P2 should wait P1 complete. So it should wait 1 millisecond. P3 can start after completion of P1 and P2. So P1 completes in 10, P2 completes in 5. So 10 plus 5, 15 millisecond it should wait. So this is the waiting time of P3. Okay, is the waiting time of P3. Directly you can write like this. Waiting time of P1 0, waiting time of P2 is 10, waiting time of P is 15. So this is individual waiting time for P1, waiting time for P2, waiting time for P3. Now we will find out what is the average waiting time for all these P3. So you have to find out, you have to add all the waiting times of P1, waiting time for P2, waiting time for 3 divided by number of process 3. So 0 plus 10 plus 15 divided by number of processes is 3. So 25 by 3 is 8.33 milliseconds. So you have to write milliseconds also. Don't simply put 8.33. You have to specify it as here they missed it actually. They have written only 10, 5. Everywhere you should write ms indicating time is in milliseconds. Next, what is turnaround time? Turnaround time is, it is a time spent in ready queue and execution time. So time spent in ready queue. See, all the three are in ready state here. So all P1, P2, P3 coming together here. So all are in ready only, ready queue only. But scheduler will schedule for first come first serve. P1 first, next P2, next P3. Next, what is the turnaround time? Turnaround time is waiting time plus execution time. How much time it waited plus execution time. So what is the waiting time for P1? P1 waiting time is 0. P1 waiting time is 0 and execution time is 10. So it is waiting time plus execution time. That is waiting in ready queue state. Okay. So waiting time is 0 plus execution time is 10. Okay. So this is 10 millisecond. Then turnaround time for P2. It is waiting 10 millisecond. It is waiting 10 millisecond and finishing in 5 seconds. So 10 plus 5 is 15. So you have to note down this is TAT for first one. This much is TAT for second one. And TAT for third one is this. So it is 10, next 15, next 10, 10, 15, 22. 10 is TAT for P1. TAT for P2 is 15, TAT for P3 is 12. So you have to write in the x-axis 10, no? After adding 5, it is 10, 15 millisecond. After adding 17, 22 milliseconds. So these are nothing but TAT for P1, TAT for P2, TAT for 3. Total turnaround time. Total turnaround time is starting from the inception. So this is all three came into ready state here only. Okay, ready queue. But scheduler schedules according to first come first serve. P1 first, P2 plus P3. So I will repeat once again. TAT, how to find TAT for P1 is waiting time for P1 is 0 because scheduler schedules first come now. So but execution time is 10 millisecond. Turnaround time for P2 is waiting time is 10 plus execution time is 15. So totally 15 milliseconds. Turnaround for P3 is waiting time is 10 plus 5. Waiting time is 10 plus 5. It is 15 millisecond plus execution time is 7. It is 22. So individual TAT for P1 is 10, TAT for P2 is 15, TAT for P3 is 22 milliseconds, and average is you have to add all these three, 10 plus 15 plus 22 divided by 3. So that will give you the total average turnaround time is 15.66 milliseconds. So this is the first problem. If you understand this, other problems you can easily do. Okay, all the problems in the module number 3, it is you have to find out average waiting time and average turnaround time only. If you understand this properly, so please remember in the non-preemptive, okay, in the non-preemptive, even if any other task comes, okay, it will complete the currently running. After that only, according to the priority, it will give. Okay, in the preemptive, the currently execution task can be preempted by higher priority. So it can stop here only. P1 will be stopped here only immediately. The scheduler will schedule the resources. But in the non-preemptive, or currently executing should complete. After that, for the next task, it will check the priority levels. So if you understand this, you can solve any problem. Thank you.